So what has been given to us in this question? Let the range of the function f of x is equals to 1 by 2 plus sine 3x plus cos 3x. So the range has been given as a and b, and they've told us that alpha beta are the arithmetic mean and geometric mean of a and b. Then we need to find out alpha beta. So before we get into the AMGM, first our task is to find out the range of this function. So how are we going to find out the range of this function? First, let me write down the function entirely. It is 2 plus sine 3x plus cos 3x. So what I'll do is I'll start writing down the range of this entire function one by one function. So first of all, I hope you all know this. You must have studied during your school time. Sin x plus cos x, what is its range generally? What is the maximum value it can reach up to? Root 2. And what is the minimum value it can reach up to? Minus root 2. If let's say you do not remember, again we'll see trigonometry chapter there you'll understand how these graph basically collaborates together to form a value that goes up till root 2, and in the negative portion it goes up till minus root 2. So if this is the case, that means whatever be the value of x that I put, it is still going to be in that range. So even if it is, let's say 100x, it is 3x, it is infinite, no sorry, not infinity, yes, even if I have infinity x, it will still be in this range only, minus root 2 to root 2. So from here I know that sine 3x plus cos 3x, its range is going to be from root 2 to minus root 2. Now what if I add 2 in all these three sides? So this would become 2 minus root 2. Here I would have 2 plus sine 3x plus cos 3x less than equals to 2 plus root 2. Now simply what I'll do is I'll do the reciprocal of this entire function, and once I do the reciprocal, what will happen is my sign of inequality would change. So if I do the reciprocal, this would become 1 upon 2 minus root 2 greater than equal to 2 plus, sorry, this is 1 upon 2 plus sine 3x plus cos 3x greater than equal to 1 upon 2 plus root 2. Now I've gotten my range. So basically my f of x, it ranges from the value of f of x, it ranges from 1 by 2 plus root 2 up till 1 by 2 minus root 2. So this is the range that I've gotten. Now they've told us that this range is equals to a comma b. So now I've gotten my value of a, which is 1 by 2 plus root 2, and I've gotten my value of b, which is 1 upon 2 minus root 2. Now what have they told us? That alpha is the arithmetic mean between a and b. So what used to be the formula of arithmetic mean? It used to be a plus b by 2. Now again, this is a concept that you have already studied about arithmetic means. If still, let's say you do not remember, for the time being, just remember it. When we study sequence and series, then we'll look at this formula once again. So what would this become? This would be 1 by 2 plus root 2 plus 1 upon 2 minus root 2 whole upon 2. So let me solve this. This would simply become, if I take the LCM, here I would have 4 minus 2, which makes it 2 whole divided by 2. Here I would have 2 minus root 2 plus 2 plus root 2. So this would become 4. So basically this comes out to be 1. So this would cancel out all of them. So we would have 1. Now if I find out beta, beta is basically the geometric mean, which is root under AB. So if I find out root under 1 upon 2 plus root 2 into 2 minus root 2. So what would I get? This would become 1 by root 2. So I've gotten my alpha and beta now. My alpha is 1, my beta is 1 by root 2. Now I have to find out the value of alpha by beta. So alpha is 1, my beta is 1 by root 2. So the value comes out to be root 2, and this is my answer. So this is how generally you can solve questions of range. It is not necessary that you always have to replace y in terms of x and then find out your range. Sometimes you can go on by dividing the functions as well. Let's look at this question now. If the domain of the function f of x is sine inverse this, so they've given us the domain. Now we need to find out exactly what is the domain for this function. So I hope you all remember, if we have sine inverse x minus 1 upon 2x plus 3, I had also repeated this domain in one of the lectures previously as well. For let's say if we have sine inverse x, then what is my domain for x? My x basically belongs from 1 to -1. So similarly I can write it down here as well. Basically my x value is this, so this would become x minus 1 upon 2x plus 3 less than equal to 1, greater than equal to -1. Now I need to find out what would be the values of x that would satisfy this inequality. So I'll solve this inequality part by part. So first I'll take this part where I have x minus 1 upon 2x plus 3 less than equal to 1. So this would become x minus 1 upon 2x plus 3 minus 1 less than equals to 0. So from here I would have, this would become x minus 1 minus 2x minus 3 upon 2x plus 3 less than equals to 0. So from here what do I get? This becomes minus x minus 4 upon 2x plus 3 less than equals to 0. So now if I take minus common and I remove it, so it would become x plus 4 upon 2x plus 3 greater than equal to 0. Now my sign of inequality would change. So this is for the first portion that I'm getting. So from here what I can see is that if this is my minus 4, this is my minus 3 by 2, this is not included, this would be included, and I have my plus minus plus here. So my answer would range from here to here. So this is the range that I'm getting, or the domain for this portion. Now let me check for the other condition as well. Then I will take the intersection of these two, because my x has to satisfy basically both these conditions, right? Where this function is less than 1 and this function is greater than -1. So now let me solve for that one. X minus 1 upon 2x plus 3. So from here what do we get? Basically x minus 1 upon 2x plus 3 plus 1 greater than equal to 0. So from here this would become 3x plus 2 upon 2x plus 3 greater than equal to 0. I'm writing it down directly. You can solve it step by step according to you. So here I would have minus 3 by 2 and here I would have minus 2 by 3. So of course 2 by 3 is not included. Sorry, here also, yes. Sorry, 3 by 2 is not included because it is in the denominator. So I have plus, minus, plus. So all the portion which is greater than 0 would be taken into account. So this basically becomes my domain for this portion. So what are the values of x that are possible that I'm getting? From the first case, I'm getting my x belongs from minus infinity to minus 4, union minus 3 by 2 to infinity. And from the case 2, what I'm getting my x value to be, it would belong from minus infinity to minus 3 by 2, union minus 2 by 3 to infinity. So now I have to take the intersection of case 1 and case 2. So if I take the intersection, what would ultimately I have in my x? My x would basically belong from minus infinity to minus 4, union minus 2 by 3 to infinity. This is what I'm going to get as my x if you take the intersection. So now they've told us that this intersection is basically, this value is nothing but r minus alpha comma beta. So how can I replace this entire equation in this format? So it would become r minus of minus 4 minus 2 by 3. Because I need to include my 4 in my minus 4 and minus 2 by 3 in my answer. So that is why they come in open brackets. So from here I've gotten my value of alpha to be minus 4 and my beta to be minus 2 by 3. Now what have they told us? We need to find out the value of 12 alpha beta. So let us solve it here. So this would become 12 times of minus 4 into beta is minus 2 by 3. So from here this 3 cancels this 4 times, minus and minus cancels out, and we get 4 4s are 16, 16 2s are 32. This is our answer. So this is how you solve questions which are related to domain. You try to convert the domain in the format that has been given in the question, and then compare the values. Now let's look at this question. This is a question of composite functions that we studied. F of x is a function where x does not belong to 2 by 3 and f of f is g of x. So first and foremost task for us is to find out what our g of x would be. It is basically f of x. That means in my f function, I need to put the value of x as f function. So basically this is f of 4x plus 3 upon 6x minus 4. So I'll simply put this value in place of x. So I would get 4 times of 4x plus 3 upon 6x minus 4 plus 3 upon 6 times of 4x plus 3 upon 6x minus 4 minus 4. So this is the value that I need to find out. So what I'll do is I'll try to simplify this so that I can find out what value exactly am I getting. So I'll take the LCM. This would basically become 16x plus 12 plus 18x minus 12 upon 6x minus 4. And this whole thing is divided by 6 4s are 24x plus 18 minus 24x plus 16 whole divided by 6x minus 4. So 6x minus 4, 6x minus 4 cancels out each other. 24x cancels out each other. So what are we left with? Here 12 and 12 cancels out each other. So ultimately we are left with 16 plus 18. What does 16 plus 18 give us? 34. So this is 34x by 34. 34 and 34 gets cancelled out and we are left with x. So basically we found out our g of x. So our g of x is nothing but x. Now we need to find out g of 4. So this is the value that we need to find out. So let me simply just start replacing the values. So what is my g of 4 going to be? My g of 4 is going to be 4 simply. What is my g of 4 going to be? So basically in my x position, I will have to put the value of g of 4. So it would be 4. Now what would be my value of g of 4? Again it would be the same thing. G of 4. And this would be equal to g of 4 and this would be equal to 4. So basically for this entire function, I'm again getting the value of 4 only because my g of x was x. Even if I try to composite this function infinity times, it is still going to remain x. So that is why we get g of 4 to be equal to 4. This is our answer. Very simple question. So you can see the level of question that JEE asks. Those are very simple and can be solved in less than 2 minutes. Now let's look at this function. The absolute minimum value of the function f of x is this, where t denotes the greatest integer function in the interval. So we have to find out basically the minimum value of this function. So you can see that inside the modulus also they've given us the same function, and in the greatest integer function also they've given us the same function. So let me assume a variable as gx and let me assume this variable to be this. So what I'll do is I'll try to find out the minimum value of this function, because since both these functions are getting added, that means I need to put the minimum value here and I need to put the minimum value here. So if I find out the minimum value of x square minus x plus 1, that is the value that we will put there and we will get the minimum value of our function, right? So this is basically a quadratic equation. And when we were studying polynomial, I hope you all remember, whenever we have, let's say, a quadratic equation in this format and a is greater than 0, that time what do we have our quadratic equation? Our quadratic equation is an upward parabola. It is going to be an upward parabola where the vertex is minus d by 4a. Sorry, where the vertex is x comma minus d by 4a. We do not care what our x is, basically we need the y value. That is what our output is going to be, right? So what would be our minimum value? Our minimum value would also be the minus d by 4a only, because it is the end point of that entire function, right? So let me find out minus d by 4a for this function. So what is my d? D used to be b square minus 4ac upon 4a. So let me find out this value. What is my b here? B is basically minus 1 minus 4 times of a into c upon 4 into 1. So from here, what am I going to get my value as? This would become 3 by 4. That means the minimum value of this function x square minus x plus 1 is 3 by 4. So if this is the minimum value, that means I simply need to put 3 by 4 in this equation. So what will I get? F of x minimum would be equal to modulus of 3 by 4 plus greatest integer function of 3 by 4. So modulus of 3 by 4 is simply 3 by 4, and this can be written as 0.75. So what is the greatest integer function of 0.75? It is 0 only. So I get the minimum value of this entire function to be 3 by 4, and this is my answer. So I hope you must have understood this portion. Of course, when we need to find out the minimum value of the function, and there are two separate functions that have been given to us, and they are in summation, that means we need to find out the minimum value of these functions and then add them up. So that is exactly what we did. We found out the minimum value of x square minus x plus 1. Using the graphical structure, we found out that the minimum value of this quadratic would be minus d by 4a. We calculated it 3 by 4, and then we substituted and got our answer. Now let's say if you do not find out this method of solving this question. So what is the other way of solving this question? Again, you would have to first write down your equation in this format only. What you can do to find out the minimum values, you can find out your g dash x. Again, you will understand this differentiation portion when we study application of derivatives, because after we studied that, of course, this first method with which we solved, you are not going to be using that. You are going to be solving with differentiation only, because it becomes very easy to solve. So from here, you see that 2x minus 1 is the differentiation. What we do is, to find out the minimum value, we equate it to 0. So from here we get x as half. That means at x is equals to half, I'm going to get the minimum value. So if I put g of x as g of 1 by 2, so this would give me my minimum value of g of x. So this would be 1 by 2 whole square minus 1 by 2 plus 1, and this comes out to be 3 by 4. So again, you found out your minimum value as 3 by 4. Now you can substitute your 3 by 4 in these two equations, in these two terms, and then get your answer. So this was another way of solving this question. So that was all for this entire chapter of functions. Of course, as I mentioned earlier, there were a lot of concepts which I told you to remember, because the proof of those concepts would come when you study the respective chapters in the future. Apart from that, keep this chapter well practiced, and you should be thorough with the concepts, because almost in each and every paper there is one question from this chapter, and the questions that are generally asked from this chapter are a kind of a combination of 2 or 3 chapters as well. As you could see, the questions that we solved, for example, this question, this was a combination of inverse trigonometric function and functions. This question that we solved, this was a combination of sequence and series, trigonometry and function. So you can see the type of questions that JEE asks. So definitely a chapter you should practice well and understand the concepts. That's all. Thank you.